A long time ago, and by long I mean absurdly, incomprehensibly long, our planet was a tropical paradise. Warm waters lapped against the shores of what is now Alaska, and those waters were full of crocodiles. Let that sink in for a moment. Crocodiles, swimming around in Alaska. The same Alaska where today you need 3 layers of clothing just to check your mailbox in January. Meanwhile, Antarctica and Australia were still one landmass, like roommates who had not yet figured out they needed separate apartments. Most of the dry land on Earth belonged to enormous creatures we now call dinosaurs. They ran the place for roughly 170 million years, which, for context, is about 850 times longer than humans have existed. And then, rather abruptly, they stopped running anything at all. Scientists have a formal name for what happened: the Cretaceous Paleogene extinction event. Everyone else just calls it the day the dinosaurs died. But what actually went down 66 million years ago? The short answer is everything went wrong at once. The long answer is considerably more interesting. Here's the math. Around 66 million years ago, roughly 1/5 of all living species on Earth vanished in what geologists would describe as the blink of an eye. That included about 16% of marine families and 18% of land vertebrate families. Now, 16 and 18% might not sound world-ending. After all, about 200 million years earlier, the planet had already survived the Permian-Triassic extinction, which wiped out roughly 60% of all species. That one was the real heavyweight champion of mass death. It nearly sterilized the entire planet. But even losing 18% of land animal families was enough to completely obliterate every functioning ecosystem on the planet. To put it simply, after the dust settled, there was not a single land animal longer than 1 meter left alive. For millions of years afterward, everything on land was small. Very, very small. Eventually, in geological terms, meaning a few million years, ecosystems rebuilt themselves. But they rebuilt without dinosaurs. Now, technically, you could argue that dinosaurs never really went extinct. Birds are their direct evolutionary descendants, tracing their lineage back to Archaeopteryx. The first dinosaur that figured out flying was a good idea. Crocodiles are also close relatives. But the iconic ones, the massive Tyrannosaurus rex, the clever velociraptors, the long-necked Diplodocus and Brachiosaurus, the marine reptiles like plesiosaurs, all of them were gone. Permanently. No sequels, no comebacks. So how do we even figure out that dinosaurs had existed and then vanished? It started in the late 1700s with a Frenchman named Georges Cuvier, who had the audacity to suggest that species could go extinct. Before Cuvier, the prevailing wisdom was that God had created every animal and plant, and they had remained unchanged ever since. Cuvier's contribution was essentially, wait a minute, what about the Great Flood? Could things have been different before it? Interestingly, Cuvier did not believe in evolution. He saw history as a series of divine creation events, followed by divinely orchestrated catastrophes. His worldview was already becoming outdated during his own lifetime, and every new fossil discovery pushed science closer to the pivotal year of 1859, when Charles Darwin published On the Origin of Species and changed everything. Darwin's theory wove countless fossil discoveries into a single, coherent narrative. But Cuvier's ideas did not disappear. For the next century, 2 schools of thought battled it out. Gradually, Darwin's camp won. By the early 20th century, the dominant view was that dinosaurs had simply lost the evolutionary race, slowly outcompeted, slowly declining, slowly fading away, suggesting that their extinction had been sudden, became almost professionally dangerous. Over the decades, scientists proposed all sorts of theories to explain this gradual decline. One suggested that flowering plants produced alkaloids that slowly poisoned the dinosaurs. Another claimed that mammals ate dinosaur eggs into oblivion. There were almost as many theories as there were scientists studying the question. And then, in the 1970s, everything changed. It turned out Cuvier had been right all along, at least about the catastrophe part. In 1977, an American scientist named Luis Alvarez found something peculiar: a metal called iridium, sitting right at the geological boundary between the Mesozoic and Cenozoic eras. Iridium is extraordinarily rare on Earth's surface, but at this particular boundary layer, it was present in concentrations hundreds of times higher than in any other known rock. The only place scientists had ever seen iridium in those quantities was in meteorites. 1 year later, in 1978, a Mexican oil company stumbled upon a massive geological anomaly on the Yucatan Peninsula, a structure more than 150 kilometers wide, spanning the entire peninsula and extending far out to sea. Its timing matched perfectly with the iridium layer. As usual, the scientific establishment initially rejected these findings, but the tide turned. Data from around the world, from the United States, the Soviet Union, Australia, Africa, began painting the same picture, a picture of monumental catastrophe. The Alvarez hypothesis gained serious traction. Yes, an asteroid had indeed slammed into Earth, leaving behind what we now call the Chicxulub crater. But here is the thing most people get wrong. The asteroid was not the only killer. The dinosaurs were already in trouble long before that rock arrived. About 72 million years ago, sea levels began dropping dramatically by nearly 200 meters. Marine ecosystems were thrown into chaos. At the same time, the climate was going haywire. While the average global temperature back then was around 25 degrees Celsius, much warmer than today, the period between 68 and 66 million years ago saw wild swings. Temperatures would plummet by 10 degrees and then snap back, multiple times. 500,000 years before the asteroid hit, things got even worse. Half of the Indian subcontinent turned into a volcanic hellscape. Enormous fissures in the Earth's crust opened up, pouring rivers of lava across millions of square kilometers. Ash and toxic gases choked the atmosphere, triggering volcanic winters. The planet froze. Acid rain changed the chemistry of the oceans. Ecosystems were battered, but not yet broken. Recovery would have been possible given enough time. Time ran out 66 million years ago. An asteroid more than 10 kilometers across hit the Earth with a force that is genuinely difficult to comprehend. Billions of tons of the planet's crust vaporized instantly, turning into ash and soot that blanketed the globe. Tsunamis taller than skyscrapers smashed into coastlines. Fragments of the asteroid, superheated during re-entry, turned the air itself into a furnace. Temperatures spiked by hundreds of degrees for several terrifying minutes. The seismic shockwave from the impact triggered volcanic eruptions around the world. In a matter of minutes, Earth went from tropical paradise to something resembling a biblical apocalypse. Scorching air, sulfuric acid rain, global wildfires, and a sky so thick with smoke that the sun simply disappeared. But the catastrophe would not have been nearly as deadly without the damage already done to the oceans. The foundation of marine life was phytoplankton, microscopic organisms that individually were nothing, but collectively were the cornerstone of everything alive in the sea. Phytoplankton fed zooplankton. Zooplankton fed fish, krill, jellyfish, and mollusks. Those fed the predators, ammonites with their enormous shells, plesiosaurs with their 10-meter necks. The climate crisis had already devastated phytoplankton populations before the asteroid even arrived. After the impact, ocean productivity dropped to nearly zero. The food chain did not just weaken, it collapsed entirely. The only marine creatures that survived were a handful of cephalopods and species partially dependent on land, like amphibians, turtles, and crocodiles. On land, the situation was different, and in some ways, more dramatic. While marine life had been slowly suffocating, terrestrial life had actually been stimulated by the climate chaos. Wild temperature swings had driven the evolution of complex, highly specialized ecosystems. Flowering plants appeared, forming intricate relationships with insects. Grasses emerged for the first time. During the warm daylight hours, the land belonged to the cold-blooded giant reptiles. At night, it was ruled by countless small mammals. Mammals sat at the bottom of the food chain. Dinosaurs dominated the middle and top. That hierarchy became a death sentence when the asteroid hit. The impact destroyed vegetation across the planet. For the first few years, daytime was as dark as a moonless night. Plants died. The specialized herbivorous dinosaurs, the giant sauropods, went first. Without them, the large predators starved. Then, the mid-sized predators. The smaller theropods held on a little longer and might have survived, but they faced brutal competition from mammals and birds that were better adapted to the new reality. Theropods had no wings to escape danger and no warm blood to endure the cold. Mammals and birds survived, but barely. 90% of their species were wiped out too. A few decades after the impact, the surface of the Earth was unrecognizable. The planet was colder, darker, and emptier than it had been in hundreds of millions of years. But slowly, painfully slowly, it began to heal. Seeds that had survived the long darkness started to sprout. The surviving organisms spread out, filling the countless ecological niches left vacant by the dead. Three groups became the great success stories of the New World. First, bony fish. Once a small and unremarkable group, they exploded in diversity and became the dominant form of fish. Most fish you can think of today have bones. That is their legacy. Second, mammals. Once tiny nocturnal creatures cowering in the shadow of dinosaurs, they climbed to the top of the biological hierarchy. Within 100,000 years of the asteroid impact, mammals had diversified explosively, grown larger, and developed specialized forms. We are one of those forms. Third, and this is the twist, surviving dinosaurs. Despite the extinction of most dinosaur species, one branch made it through: birds. Their ability to fly and their relatively small size gave them a massive advantage. Today, there are more than 10,000 species of birds. The dinosaurs did not entirely lose, they just changed shape. Next time a pigeon steals your sandwich, remember you are being mugged by a dinosaur. A million years after the extinction event, Earth was teeming with life again. But it was a completely different world. New climate, new ecosystems, new dominant species, and not a trace of the giant reptiles that had ruled for nearly 200 million years. So what is the takeaway? The Cretaceous Paleogene extinction was not one thing. It was a cascade: volcanic winters, collapsing ocean chemistry, climate chaos, and then, as a final devastating blow, a rock from space the size of a mountain. Life survived, as it always does. It adapted, as it always does. The dinosaurs are gone mostly, but their descendants are everywhere. And somewhere in the distant future, another intelligent species may look back at our fossils and wonder what happened to us.